Have you ever stared at a spreadsheet just until your eyes completely glazed over? Yeah, we've all been there. But what if I told you that hidden inside all those rows and columns of numbers, there's actually a story just waiting to be told? Well, today we're going to learn how to unlock those stories using the simple but really powerful tool of graphs.
You know, we're often presented with information that just looks like a wall of numbers. It can be super intimidating, but hidden inside that wall, there's always a story. The trick is just knowing how to get it out.
Okay, take a look at this. It's a pretty typical monthly budget for a family. Now, you can scan down the list, sure, but can you instantly tell what their biggest expense is? Or how education costs stack up against, say, fuel? It takes a second, right? You kind of have to scan it, compare the numbers, and that's the problem with raw data. The story is buried.
So, here's the game plan. We're going to build our data storytelling toolkit piece by piece. We'll start with why a picture is worth 1,000 numbers, then we'll get our hands on the classic bar graph, dive into histograms, and even uncover a really common trap that can make data lie. After that, we'll connect the dots with something called a frequency polygon, and then wrap it all up by learning how to choose the perfect tool for whatever story you're trying to tell. So, first things first, why even bother with graphs at all? Well, the simple answer is that our brains are just wired to process visual information way faster than lists of numbers. Graphs make comparing things incredibly easy and intuitive.
And hey, this is not a new idea. You've heard the classic saying, right? One picture is better than 1,000 words. Well, when it comes to data, I'd say a good graph is worth 1,000 numbers. Easy.
All right, let's grab the first and most fundamental tool for our toolkit, the bar graph. This is your workhorse, your go-to for comparing individual, separate things.
So what is it really? A bar graph just uses these rectangular bars to represent different categories. Now, there are a couple of key things to notice. The bars are all the same width, and there are gaps between them. The real story, though, is told by the height of each bar. That's what shows you the value.
Remember that family budget? That wall of numbers? Well, look at it now. Bam! The storage just jumps right out at you. Instantly, you can see that rent and education are the two biggest expenses, towering over everything else. You can see they spend more than double on those than they do on medicine. The story isn't hidden anymore. It's right there, clear as day.
Okay, so bar graphs are great for separate categories, but what happens when your data isn't so neat and tidy? What if you're looking at a continuous range of numbers, like people's weights or test scores? For that, we need a totally different tool, the histogram.
Here's a histogram showing the weights of 36 students. The very first thing you'll probably notice is, hey, where'd the gaps go? Unlike the bar graph, the bars are all squished together. And that's on purpose. It's because the data is continuous. One weight range flows right into the next. Let's just put them side by side so it's super clear. A bar graph is for discrete, separate items like grocery, rent, fuel. A histogram is for continuous ranges of data like weights. Bar graphs have gaps. Histograms don't. And here's the really key difference. In a bar graph, the width of the bar doesn't mean anything. But in a histogram, the width is super important. It represents the range of data in that bar. Okay, now for a pro-level tip. Histograms are powerful, for sure, but they can also be really deceptive if you're not careful. Let's talk about something called the unequal bins trap. So, picture this. A teacher grouped student test scores, but the groups have different sizes. You see, the first one covers 20 marks, but the last one covers a whopping 30 marks. A student then made this histogram. At a glance, it looks like a lot of students scored between 70 and 100, right? That bar is pretty tall. But this chart is lying to you. It's giving a completely misleading picture of what happened on that test. Before I tell you why, just take a close look. Can you spot the trick?
Okay, here's the secret. With histograms, it's the area of the rectangle that represents the frequency, not just the height. Now, when all the bars have the same width, it's fine to just look at the height. But when the widths are different, like they are here, just looking at the height gives you a totally false impression.
So, how do we fix this lie? We have to adjust the heights of the bars so that the areas are proportional. We find the smallest width, in this case 10, and we make everything relative to that. So for that 0 to 20 group, which is twice as wide, we have to cut its bar height in half for the graph. And for the 70 to 100 group, which is 3 times as wide, we have to divide its height by 3. And would you look at the difference? It's night and day. On the left, we've got the lie, with that last bar looking really impressive, but on the right, we have the truth.
Once we adjust for the area, we see that the 70 to 100 range actually has the lowest frequency density of all. It's a completely different story, and now it's the true one.
All right, let's add one last tool to our kit. If a histogram shows the data in blocks, a frequency polygon shows its shape by connecting the dots. You know, the easiest way to understand a frequency polygon is to just imagine taking a histogram and playing connect the dots with the midpoint on top of each bar. It gives you a really quick, clean visual of the data's shape and how it's distributed.
But here's the cool part. You don't even need to draw a histogram first. You can make one directly from the data. First, you find the midpoint for each data group. Then, you plot that midpoint against its frequency, connect the dots with lines, and finally, just anchor the ends of the line down to the horizontal axis.
That midpoint has a special name, by the way. It's called the class mark. And the formula to find it is super simple. You just add the upper and lower limit of your interval and divide the whole thing by 2.
So there you go, 3 powerful tools to help you turn raw data into a compelling story. But the big question is always, how do you know which one to use? Well, it all comes down to what you're trying to show. Okay, let's do a quick recap. Use a bar graph when you're comparing separate, distinct categories. Use a histogram when you're showing the frequency of continuous data. And always remember that unequal bins trap. And a frequency polygon is fantastic for just seeing the shape of your data, or especially for comparing multiple data sets on the same chart.
So, you now have the fundamental toolkit for data visualization. You can turn a confusing table into a crystal clear bar graph, a continuous data set into an honest histogram, and see the real shape of your data with a frequency polygon. So the only question left is this: what story is your data waiting to tell?